So that is our example one. Now in example two, we want to deal with the PDF, which is linear and non-linear at the same time. We want to see a case when the PDF is compound. So example two, it says that a random variable x has a PDF small f of x given by, so our small f of x is k into x plus 2 squared. That is when x lies between negative 2 and a 0. It is a 4k, that is when x lies between 0 and 4 over 3, and it is 0 elsewhere. So if it is like that, where k is a constant, where k is a constant. So if it is like that, they may require us to part a times log 1, the value of k, log 2. They may require us to find the probability negative 1 is this equal to x, this equal to 1, log 3. They may want us to find the probability capital X is greater than 1. Now in your free time, part B, they will want us to sketch f of x. Now our main interest is in how we sketch these graphs, because we saw how you can integrate and find the unknown, and also how you may look for the unknown probabilities. So I request the class that in your free time you can try and check whether these values are very correct. So in our solution, the value of k, which is log 1, you will check and see whether it is 1 over 8. Then log 2, which is the probability 1, is negative 1, is this equal to x, this equal to 1. You will check and see whether the answer is 19 over 24, and then log 3, which is the probability x is greater than 1. You will check and see whether the answer is 1 over 6. Then for us, or for me, I would wish to begin with the part B, which is the sketch of f of x. And because we are dealing with how to sketch the nonlinear PDFs, then that is where we should begin from. The order of the question is very important. So because we have found the value of k, it means we are going to sketch when the value of k is known. So I will first redefine my PDF. So our f of x is where there is k. I want to put this value of k. So it is 1 over 8 into x plus 2 squared. This is when x lies between negative 2 and 0. It is a 4. It is a 4 over 8. So 4 times 1 is 4 over 8, which is as good as 1 what? Okay, let me keep it as 4 over 8. That is when x runs from 0 up to 4 and a third, and it is 0 elsewhere. First step, identify f of x for the different intervals. So find the values at endpoints and then you sketch. But this one is non-linear, therefore we need the values at endpoints. We also need the turning points and their nature, plus the intercepts if possible. Then we are going to begin with the values at endpoints. We have already identified it. F of x is equal to 1 over 8 into x plus 2, the whole thing squared. This is the nonlinear PDF. So we are determining the values at endpoints, but we shall also determine the turning points and their nature. So my f of x is that is when x lies between -2 and 0. I'll begin with this first one, which is the -2. So these are now the values at any points for the first PDF and its inter. When x is -2, our f of -2, we substitute in this function. Where there is x, you put -2. So we shall have 1 over 8 into -2 plus 2, the whole thing squared, and our f of -2. -2 plus 2 is a 0. Times 1 over 8 is a 0, which means that this nonlinear PDF must start when x is -2. F of x is a 0. And it is going to end, because it's running from -2 to 0, it will end when x is 0. So the other end, x coordinate is 0. So when x is 0, our f of 0 is going to become 1 over 8 into, where there is x, you put a 0. So into a 0 plus 2 all squared, and our f of 0 is going to become 1 over 8 into a 4. So our f of 0 is 4 over 8, and the point plot then will become, when x is a 4, f of x is 4 over 8. There is a reason for keeping it as a 4 over 8, and we shall see it when it comes to sketching. So those are the values at endpoints for our nonlinear PDF. It is meant to begin at -0 and it will end at 0, 4 over 3. After finding the x-coordinate of the turning point is negative 2, because this is what we have obtained after equating the first derivative is 0. Now the turning point must be in the form x comma f of x. So having obtained the x-coordinate as a result of equating the first derivative to 0, we are now going to get that x-coordinate and we put it in the original function of the PDF. So our f of x is a 1 over 8 into x plus 2 squared. That is the original nonlinear PDF. Now its x-coordinate of the turning point is negative. So when fx is negative 2, our f of negative 2 becomes 1 over 8 into negative 2 plus 2, the whole thing squared. And our f of negative 2 will now become a 0. So after it becoming a 0, remember we must have the turning point in this form. We write the x-coordinate followed by the y-coordinate. So that turning point is going to become negative 2 and 0. It's only one turning point because after differentiating, we got only one value of x. But where you get to, you still get all the y-coordinates of the two x-coordinates that are obtained at this level. So we are progressing after getting that. Those are that's the turning point. Now we need its nature. We need the nature of our turning point. So to get the nature of the turning point, we are going to adopt one approach. We are now determining the nature of our turning point, which is negative to 0. So for the nature of our turning point, which is negative to 0, we are going to use the second derivative because it takes us there first. But you can also apply the table of the first derivative and you check what happens on the left hand side of the x-coordinate of the turning point and also on the right hand side. You will definitely get the same nature of the turning point as that we are going to obtain here. So our f of x was originally 1 over 8 into x plus 2, the whole thing squared. So that f of x was x squared plus 4x plus 4. When you differentiate it the first time, we get our f prime of x as the 2x plus 4. So when you differentiate it again, we get our f prime of x as the 2 over 8. Now we are supposed to inspect when t is negative 2, 0, the x-coordinate of that turning point is a negative 2. So we want f double prime of negative 2. We are substituting in this. So where there is x in this, we are going to put a negative. And because this is a constant, we shall remain with the 2 over 8. Because we don't have anywhere where we shall substitute the negative 2 on the right hand side, so it remains a constant. Now having obtained f double prime at the x-coordinate of the turning point as this, we can now conclude about its nature. So since f double prime of negative 2, which is 2 over 8, is greater than 0, then the turning point, which is negative to 0, is a minimum. If this approach is very said, in the first step, you may choose to go the sign of the first derivative, both on the left and also on the right. So this is the sign of f prime of x. Our turning point is negative 2, 0, and f prime of x is 1 over 8 into 2x plus 4. This is the 1 over 8 into 2x plus 4. So we need what happens. This is when x is negative 2. What will happen on the left and on the right? On the left, you pick a value which is less than negative 2, and on the right, you pick a value that is greater than negative 2. So when you pick a value, this is going to be the slope. You can either use this. If it is complicated, then you can choose to understand that. Pick a value less than negative 2. For example, pick negative 3. Put it here. 2 times negative 3 is negative 6. Plus 4, negative 2. Times 1 over 8 is a negative. So the sign is going to be negative. Put in a negative 2. 2 times negative 2, this is 2x. So 2 times negative 2 is negative 4 plus 4, that is a 0, will be a 0. Pick a value greater than negative 2. For example, you can pick a negative 1, or you can even pick a 0. 2 times 0 is 0 plus 4, that is a 4. Times 1 over 8, 4 over 8, which is a what? Positive. We are interested in the sign, not the result. So you can pick different x coordinates before and after, on the left and on the right, but the signs will not always change. Though it is advisable to pick values that are closer to the x coordinate of the turning point. So when it is negative, it moves like this. If it is 0, it's a constant, and if it is positive, it will ascend like that. And once you get a U-shaped curve, it means that the turning point, which is negative 2, 0, is a minimum, because it is forming a U-shaped curve. Now, having obtained the turning point and also its nature, let us now go for the intercepts. Yeah, intercepts. So for the intercepts, like we said before, there are 2 intercepts. At the x-intercept, that is when f of x is 0. Now my f of x is 1 over 8 into x plus a 2 all squared. So when f of x is 0, it means 1 over 8 into x plus a 2 all squared is equal to a 0. When we multiply all through by 8, our x plus a 2 all squared is a 0, and x plus 2 will be 0, which means that either x plus 2 is 0 or x plus 2 is a 0. So we are going to have x plus 2 as a 0, which means x is negative 2, and it is a repeated. It is a repeated value because we have the same brackets there. So it is only one x coordinate of the intercepts of the x-intercept that we have. So my first intercept is when x is negative 2. Of course, f of x was a 0. Now the last intercept, that will now be the f of x-intercept, where the curve is meant to cut the f of x axis. So at the f of x-intercept, which we would call the y-intercept, so at the y-intercept, x is 0. We are replacing y with f of x in what we are discussing. So at the f of function was compound, we are heading for the second part in which our PDF was defined, and then we shall definitely sketch. So we are done with the first part. It is only the intercepts, these notice may be in your margins of the books, that the intercepts are only found in most cases for the first part of the PDF if it is compound, where it is defined for more than one interval. So in the next interval, you do not bother to find the intercepts, though they are not always very relevant. If you can really get the values at endpoints and the intercepts, you can choose to avoid them, but you always find them so that you can see how the graph can move. So our f of x was compound. To remind you, it was 1/8 into x plus 2 squared. This is when x runs from negative to 0. It's a 4/8. That is when x runs from 0 to 4/3, and it was 0 elsewhere. So we are done with that part. Now we want to progress to the next part, which is this. So my f of x, identifying f of x for the next interval. My f of x is 4/8. This is when x runs from 0 up to 4/3. After identifying it, because this is, you ask yourself, is it linear, non-linear? This one is a linear PDF. And because it's a linear PDF, I only need the values at any points. So to get the values at any points, I use the first x coordinate and the last x coordinate of the interval. So when x is 0, my f of 0, I substitute in this, is going to be 4/8 because this is a constant function, and the first endpoint is going to be 0 and 4/8. The second endpoint is when x is a 4/3. So my f of 4/3, we are substituting in this, is going to be a 4/8, and my endpoint, which is the final point for that linear PDF, is going to be 4/3, then 4/8. Then 4/8. Now that we are done with the finding the values at endpoints of that nonlinear PDF, we can now go ahead and we sketch